Good morning, everyone. Today we are going to see about the vapor architecture, vapor cells inserted architecture. So you see here, we in my previous video, part one, we have seen the dedicated vapors and shared vapor cells. So how vapors are operated in test mode and ex-test mode. So now in this part two, so we'll look into the how core is connected to the vapor cells. So what are the vapor cell registers? Everything we'll look. You see here, this one is a core. This is a core. So these are the vapor boundary registers. Vapor boundary registers are surrounded by the core. So these, with the help of these registers, we can able to shift the data into the core or capture the data from the core. Or if you want to test the logic between the cores, we are going to use the vapor boundary registers to shift in, shift out the data. Okay. Now, you see here vapor bypass registers. Whenever this one is a vapor bypass register, suppose if you want to bypass this particular testing of this particular logic, so we can use a vapor bypass registers. Vapor instruction decoder will get the instructions from the vapor instruction registers. So these are from the top model. The instructions are coming from the top model to this one vapor decoder. Based on the decoder instructions, it may decide. So we'll go to the next slide. We'll understand how these are connected. Yeah. So these are the vapor registers which are there in our previous slide. So these registers, so they clearly written here. So these registers are types of vapor registers, vapor boundary registers, bypass registers, instruction registers. So we have another type. So vapor data registers, vapor instruction registers, internal scan chain registers. So these are the registers, categories, and the registers which are used in vapor cells. So in vapor boundary register, you see, vapor boundary register is surrounded by the core. Core. So these are the vapor cells. We may use the shared vapor cell or dedicated vapor cells here. So you see here, this one is a vapor bypass register. So whenever this vapor bypass register got enabled, so if you see here, vapor bypass registers are enabled here. So the vapor input is going to here. It is bypass the core logic. Vapor input and vapor output. Vapor inserted SI to SO. This one is it allows the data flow from input to the output without passing through the data registers in the core. It is easy to bypass the target core when it is not needed for testing. It will reduces the chain length that leads to a decreasing in the test time. Chain length is reduced means it will decreases the test time. How chain length, reducing of chain length decreases test time means in order to ship the data into the scan chains. So we should require if the 100 scan cells are there, we require a 100 clock cycles to ship the data in from the 100 scan. So next one is vapor instruction registers. Used to transfer the instruction from chip level to the core level. So here we are looking at the core level. From the chip level, if you want to transfer the instructions, it will be useful for the vapor instruction registers. So it is easy to store the instructions which is determine the test mode and generate the control signals based on the loaded instruction. This instruction also specifies the target vapor data register to which the data should go. So instruction decoder, we have an instruction decoder here. It is responsible for decoding a binary code of an instruction into the corresponding control signals that tells the core what to do. It will receive the instructions from the IR instruction registers. Yeah. So these are the vapor cell architecture types. Let me clear all this. So you see here, so this is a dedicated vapor cell and this one is a shared vapor cell. Dedicated vapor cell architecture, which consisting of when scan enable is one. So we have to shift the data. From where we have to shift the data? Primary input. So SI to S scan input to scan output. So we have to shift the data. This is a dedicated vapor cell. So here is also we have to shift the data SI to S. So here this is dedicated and this one is shared one. Shared vapor cells or pre-existing vapor cells are used for the uh, vapor cells used as a vapor cell. Pre-existing vapor cells are scan cells are used as a vapor cell, that is a shared vapor cell. Dedicated vapor cell, separate shell is inserted, so it may increase the area. Now you see here the capture operation, how to capture the data. So the data capturing can be done from the primary input to the flop. Primary input to the flop. So where we are getting the primary input, this is the primary input, it is loaded and bypassed like this and it is coming like this. So primary input capture operation. Vapor cell capture the test response from the internal or external logic based on the in-test or X-test mode. During this phase, data from the input pin of the vapor cells is transferred to the flop. Input pin, that is a primary input pin, it is transferred to the flop. So this is a dedicated vapor cell and this one is a shared vapor cell. Yeah. Till now we have seen about the shift operation. Now we will see about the capture operation. So to see a capture operation, we will see here. Yeah. Capture operation. What we are going to do? We are going to, sorry. Yeah. See, this one is dedicated vapor cell and this one is a shared vapor cell. This one is a shift only. SI to SO shift only. This one is SI to SO shift only. Shift operation image. Yeah, this is shift operation image. So we have to look into the capture operation image, normal operation. So during the normal operation, so in the normal operation, so PI to PU, primary input to primary output, vapor sensor gets bypassed. Primary input to primary output, vapor sensor bypassed. So the additional test mode pins added for the vapor core include the clock port, data input port, reset port. If resets and vapor boundary registers to a known state, it is an optional update vapor, capture vapor, shift vapor, select vapor input ports, data output ports, enable port. So these are the pins we are using for the vapor operation. So yeah, stuck at capture operation. During capture operation, so it has to capture the data from PI to cell. So this is about all the vapor cells.